This video segment examines industrial greenhouse gas emissions and the potential for their mitigation. Its major points are: number one, most of the greenhouse gas emissions from industry are energy related, yet energy efficiencies of most industrial processes are less than half of what is theoretically achievable. Number two, electric motors, their controls, and their transmission systems are primary targets for energy conservation in the industrial sector. Number three, greater efficiencies in generating and delivering steam are readily achievable. Number four, steel and cement production, the two largest industrial emitters, have industry-specific remedies. Industrial emissions of greenhouse gases, if one includes emissions from electricity and steam generated off-site, amounts to 3.3 billion kilograms of carbon equivalents per year. Industries with the highest emissions are A, metal smelting, especially steel, iron, and aluminum; B, extraction and refining of petroleum; C, cement manufacture; D, pulp and paper processing; E, industrial nitrogen fixation to generate ammonium; and F, synthesis of ethylene, a precursor of many plastics. As the human population and per capita income have grown, so has production of industrial goods. Since 1980, global annual production of steel has increased 84%, petroleum 40%, cement 271%, paper 180%, ammonia 200%, aluminum 223%, and ethylene 194%. The industrial sector, however, has not expanded as quickly as some other sectors, such as transportation. And actually, the industrial share of greenhouse gas emissions has declined from 40% in 1971 to 37% in 2004. Many heavy industries have relocated from developed countries to developing ones, such as China and India. Indeed, industrial greenhouse gas emissions from China and India rose from 12% of the world's total in 1971 to 42% in 2004. Because expected lifetimes of manufacturing equipment, power lines and pipelines, and power stations extend from 10 to 50 years, industrial facilities under construction now in China and India will influence emissions for decades to come. Over 80% of the greenhouse gas emissions from industry are energy related, yet energy efficiencies of most industrial processes are less than half of what is theoretically achievable. Increasing energy efficiencies in the industrial sector thus presents an excellent opportunity for diminishing greenhouse gas emissions as well as saving money. Strategies to achieve this include upgrading equipment, optimizing operating procedures, improving equipment maintenance, and maximizing capacity utilization. Most industrial equipment, including pumps, compressors, fans, and conveyors, contain electric motors. These motors consume more than 60% of the energy in the industrial sector. Therefore, the motors themselves, their controls, their transmission systems are obvious targets for energy conservation in the industrial sector. Premium motors have stronger magnets, higher conductivity brushes, and better bearings than their standard counterparts, and are 3 to 30% more energy efficient, but about 20% more expensive. In industrial applications that run motors for extended periods, the lower energy requirements of premium motors compensate for their higher purchase price in less than 3 years. Motors operate most efficiently when loaded at between 75% and 100% of their capacity. Electronic adjustable speed drives vary the frequency and voltage of the electricity supplied to a motor to control its speed. Adjustable speed drives are expensive, costing roughly the same as the motors they control. Yet under variable loads, they improve energy efficiencies by 10 to 20%, and the energy savings quickly compensate for higher capital costs. Transmission systems connect motors to their loads via belts, chains, or gears. V-belts are the most common type and may reach efficiencies of 95% if properly installed and maintained, but typically have efficiencies of less than 90%. Replacing V-belts with cog belts or gears increases energy efficiencies by an average of 4%. In some circumstances, an adjustable speed drive permits a direct connection between the motor and the load, eliminating the need for a transmission system.